Okay, so a lot of you did not seem to get the paper portion of homework number 2. You didn't get the point, or even if you got it right, you still didn't totally see why it was a second fundamental theorem of calculus problem. So I just want to go through that now, rather than using our class time for that. So the key idea here is you are given the definition that g of x is the definite integral from 0 to x of f of t dt, which we've seen this kind of function before. This was defined when we were talking about about the second fundamental theorem of calculus. Sorry, I have to just change to my inking options. Okay, sorry. And so we have this function means that for every input x, we find the signed area from 0 to that value under this curve f. Okay, so to begin, if I want to find g of 1, which is what goes here, I'm finding the signed area, the definite integral from 0 to 1 under f of t dt. So that's going to be the area right here. So that box has an area as a width of 1 and a height of 1, so it has an area of 1. G of 2 would be the definite integral from 0 to 2 of f of t dt. So, sorry, my daughter in the background. So that's going to be the area between 0 and 2 under the curve f of x. So that's this whole area, both these boxes, so that's going to be an area of 2. When I go to g of 3, I'm now finding the signed area under the curve between 0 and 3. So that's this positive area of 2, and then plus this negative area down here, and that has, this rectangle right here has a height of -2 and a width of 1. So this is an area of -2. So I've got +2 plus a -2, so this is 0. And I continue in this way to fill out the rest of the chart. So g of 4 is going to be the integral from 0 to 4. Sorry, my daughter's in the background. So we've got the positive area of 2 plus the negative area of 2 plus the negative area of 2. So that gives us a total of -2. And we keep going like this to fill out the chart. And so the next value would be, we're going to add another -2 to it. So that's -4. And then for the next value, we're going to add another -2. Hi, sweetie. And then finally, when we get to the area from 0 to 7, now we're finally starting to add up some positive area again. So we've got all this negative, and then finally when I go to 7, we're adding some positive. So now it's going to add 3 more units back, these 3 units, and I'm going to be up to -3. And then again, from that point on, I'm adding another 3 units because that's the area of these boxes. So every one of these I'm going to be adding 3 more. So this goes to 0, then 3, then 6. So that's how we define the function, and then you should have been able to plot those points to get something that looks like we're starting at 1, 1, and then we go up, then it's decreasing at a slope of 2, and then it's increasing at a slope of 3. Something like that. This is just a sketch. So all of that was part A, and I was a little bit generous with grading on these things with you, because now of parts B through F, if you answered the question correctly based on your wrong data, I tried to give you points for this, but so let's see what you should have found. So part B asks us to find, I'm sorry, part B was to plot, sorry. Part C is to find where does G, this is G, remember, right? This was the graph of F. Some of you answered questions about F. This is the graph of G, right? That's what our definition is. So where does G have a minimum? So let's look at it. We have the graph. We could see the minimum. The minimum is right here. If you were careful about plotting that, that's when x equals 6. So the minimum was here. So this is the point 6 comma -6 is the minimum. Part D was where does G have a maximum? Well, we have a local maximum here, but we have an absolute maximum here. So really it was looking for this absolute max, which is the point 10, 6. If you said a local max, I hear what you're saying, but it's not the absolute one. So now we were supposed to explain, so I want to point out something about this. This is where we connect to the second fundamental theorem of calculus. When we usually want to find a maximum or minimum on a curve, what we usually do is we look at the derivative of the function, and we look to see where does the derivative have a critical point. So we're looking at like where does G prime, where is G prime either 0 or undefined. That's what a critical point means. So if you're trying to find where G prime is 0 or undefined, this is G, not G prime. So we want to go back to what is G prime? Well, if G of x is this thing, G prime is the derivative of this integral, which the second fundamental theorem of calculus tells us is just f of x, right? And then times technically the derivative of this, which is 1, so just f of x. So we're really asking ourselves, where is f of x 0 or undefined, right? So it shouldn't be surprising here that we have, and not just 0 undefined, but for it to be a maximum or a minimum. So that's where we find critical points. Those are our potential max or mins. In order for it to actually be a max or min, a minimum would be where the graph goes from decreasing to increasing. So the derivative would be going from negative to positive. So notice that here's our minimum going from 6 to negative 6. We're going from a negative to a positive. Now, because f is not continuous, we're not seeing it actually, we're seeing the curve just jump, right, from this piece to this piece. But we do have the derivative here, which is f. Remember, f is now our derivative, g prime. Our derivative is changing from a negative value to a positive value, and we see that the derivative would be, so that would make our function have a minimum here, right? We're going from negative to positive, so decreasing to increasing, which we see visually here as a minimum. Notice also that the derivative at this point would be undefined, right? Because the derivative of g has these like corners. These corners here make the derivative undefined. So, okay, so I'm trying to connect again to the second fundamental theorem, which I think a lot of you missed the idea, and that's fine. So that's why I want to explain it. And then likewise, the local max, we also have it undefined there. Actually, at the actual max, we only have a one-sided derivative. So, all right, anyway, so that's our connection to our second fundamental theorem of calculus. And then we can answer more questions. Like part E says, on what interval does g increase at the greatest rate? So you can actually just see what's happening here, that it's increasing at the greatest rate here because the slope here was 3. So it was increasing on the greatest rate all the way from the values from 6 to 10. This is not a point now. This is an interval. And in terms of the second fundamental theorem of calculus, well, in terms of the area, we see that the reason it's we're increasing the most is because we're adding an area of 3 every time. In terms of the derivative, we're asking on what interval does g increase at the greatest rate? We're talking about the derivatives, the second derivative, because we're talking about the rate at which the derivative is increasing. And so if you think about our second derivative here, if f is our first derivative, the second derivative would be all the slopes of here. These are all going to be having a slope of 0. So we're not getting much information thinking of it in that context. So the second fundamental theorem of calculus isn't really helping us much, but we do see our connection back to our graph of g, that certainly this is where the slope is increasing the most because this is where we're adding the most amount of area. And then finally, part F, we were asked to identify where are the zeros of g, which we can, again, just visually see right here as these two values here. So that was the point 3, 0 and 8, 0. And what that means in terms of the area is that's the points where the amount of positive area we had canceled out with the amount of negative area. So we can understand that in terms of our areas as well. So anyway, that's what I was expecting you to do for the paper portion of the homework. And hopefully you can understand how I got this table of values now if you didn't get it when you were doing the homework yourself, because this is an important idea for you to understand, this definition. And hopefully, even if you were able to answer these questions without viewing the second fundamental theorem of calculus, maybe now you have a little bit more insight as to the connection there.